Okay. So last time we sketched the graphs of sine and cosine. And we'll cover them when we need them. But let's start with this. Let's try to graph tangent. Any reasonable list of the trig functions, tangent is one that should come after sine and cosine. So let's try to sketch the graph of that thing. And let's remember the definition that tangent is sine over cosine. And just like what we did when we graphed sine and cosine, we'll start by figuring out what the period is. So what we do, we'll try to graph tangent over one period, and then we'll repeat that graph over all the remaining periods. So in order to figure out the period, start out by telling me this. What's the tangent of x plus pi? And let's walk it out. Unless you just already know the answer, let's talk through how to discover this. What is tangent in terms of sine and cosine? Sine over cosine. So tangent of x plus pi is sine of x plus pi over cosine of x plus pi. And what happens when you change an angle by adding pi to it? What happens to its sine and cosine?
They both go negative.
They both become negative. And now you see the negative signs will cancel. And so what do you wind up with? Tangent again? Aha! Aha! So if you take tangent and change its argument by exactly pi, you get the exact same function back. So the graph of tangent, if you shift it right by pi, you should get the exact same graph again. Yeah.
The same notes as yesterday.
Aha. How many people don't have the notes that I'm actually pointing out right now? Just you? Those are. Yeah, so what happened is I made the mistake of handing out these notes maybe 2 minutes before class actually started. So since you weren't like 2 minutes early, instead you showed up on time, you didn't get it. Oh. And then I also handed out the old notes because I still had them. Okay, nice. So that means that we can shift tangent by a total of pi and get the exact same graph back. So the period of tangent is pi. What does that mean? That means that if we can graph tangent from 0 to pi, then we should just be able to repeat that image over and over again and get the graph of tangent over the whole of the real line. So the plan that we'll follow is we'll graph from 0 to pi, then we'll repeat whatever we get. There's the graph of tangent. And let's see, tangent is built out of sine and cosine. So let's start with the graph of sine and cosine. And maybe what I'll do is, I don't know, I'll sketch both of them and you'll tell me which one is which. There's the graph of either sine or cosine from 0 to pi. There's the graph of either sine or cosine from 0 to pi. Tell me, which one's which? Is the pink one the graph of sine or the graph of cosine?
Sine.
Sine. Why sine? How could you tell?
Goes to the origin.
Goes to the origin. So the other one must be cosine. And importantly, right, these are actually positive and negative in the right places. Sine has this x-intercept at pi over 2, cosine has an x-intercept at 0, and then another one at pi. So, if we can understand those two functions, then we just have to like divide one by the other, and that'll tell us what the graph of tangent should look like. So let's start by even just figuring out positivity, negativity. Check out the graph of cosine. Where is cosine positive if I am only allowed to look between 0 and pi?
0 to pi over 2.
Cosine is positive from 0 to pi over 2. And maybe I'll try to keep my color coding consistent. So cosine is positive from 0 to pi over 2. And then it's negative from pi over 2 to pi. What about sine? Where is sine positive or negative?
0 to pi.
0 to pi. Over the whole of the interval that I'm actually looking. And tangent is sine over cosine. So between 0 and pi over 2, tangent will be cosine, which is positive, divided by sine, which is negative. So from 0 to pi over 2, will tangent be positive or negative?
Negative.
Oh, I fucked up. So should tangent be positive or negative?
Positive.
I didn't just accidentally swear at you guys, did I? I feel like I might have. Okay, I apologize.
We're big kids.
From pi over 2 to pi, positive or negative?
Negative.
Negative. So that tells us a lot, right? That tells us where tangent is positive and where it's negative. So I know for a fact, this is where I'll try to graph it. From 0 to pi over 2, it better be positive. From pi over 2 to pi, it's going to be negative. Now let's start thinking about where it's 0 and where it has a vertical asymptote. So tangent is sine over cosine. It'll be 0 when the numerator is 0. But look at the graph of sine. Between 0 and pi, when is sine equal to 0?
At 0 and pi.
At 0 and at pi. So tangent will be 0 at 0, and it will be 0 at pi. Just like a rational function, this thing will have a vertical asymptote when you accidentally divide by 0. Where is the denominator 0?
Pi over 2.
Pi over 2. Right? Because you could look at the graph of cosine and say, yeah, there's this intercept at x equal to pi over 2. So there should be a vertical asymptote at pi over 2. And now let's just try to sketch between. So from 0 to pi over 2, it's going to be positive. So it has to become positive just after 0. And there's going to be this vertical asymptote at pi over 2. Is the vertical asymptote going to be passing to positive infinity or negative infinity right there? Positive, right? Because it can't be negative. You know it's positive from 0 to pi over 2. Similarly, from pi over 2 to pi, it will be negative. So just before pi, this tangent function will be negative. And now I just need to achieve that vertical asymptote. Can't go to plus infinity because it's negative, so it has to go to minus infinity. So there's the graph of tangent from 0 to pi over 2. 0 to pi, rather. And let's maybe even just check this by remembering tangent is like the slope of the line from the origin to a point on the unit circle. So I can do this here. Let's check it this way. Let's draw a picture of the unit circle. Tangent is the slope of a line. So let's see. The slope of that line where I rotate by an angle of 0, that slope is 0. So tangent of 0 should be 0. That's good. You start increasing that angle. Are these slopes positive or negative?
Positive.
Positive. And they're getting super duper steep?
Yeah.
until you get to an actual right angle, and that's not actually a slope, that's vertical. Its slope in some sense is 1 over 0. So it should get super duper steep. So you see this vertical asymptote. Just after that right angle is this line. Does it have positive slope or negative slope? Negative. And it's a negative really big number for the slope. And then the slope decreases until you get down to an angle of pi when the slope is 0. So yeah, that graph seems to check out with the geometry. Nice. So that means that we have the graph of tangent from 0 to pi. There it is. How could you now get the graph of tangent over the whole of the real line? What was the whole plan, right? Tangent has period equal to pi. So if I shift this graph by pi, I should get the exact same graph again. So I'll exactly copy this and paste it between pi and 2 pi. And then again between 2 pi and 3 pi, 3 pi and 4 pi, and then I'll go backwards also. Cool. So let's read some things off of this graph. Even or odd? Or neither?
Odd.
Odd, I think it's odd. And if you want to check that, all right, so what does odd mean? It means fix the origin, take the graph and rotate it 180 degrees. Do you get the exact same graph back? Yeah, modulo my inability to draw consistently. Is tangent ever decreasing?
No.
No, never decreasing. Where does tangent have an x-intercept?
Intervals of pi.
At every multiple of pi's. 0, pi, 2 pi, it's got an x-intercept. Where does this thing have a vertical asymptote?
Every interval of half pi.
Almost. Like every. Well, let's write it down this way. So I see a vertical asymptote at pi over 2. But then I also see a vertical asymptote whenever you shift that by pi. So at every pi over 2 plus pi k. X-intercepts at every multiple of pi is this function. Yeah.
Can you saw the picture?
Oh yeah, you actually want to see what I wrote. That's fair. Still readable though? Okay. Where is this function increasing? Let's ask a different question. Where is this function decreasing? No, there's no point where it has negative slope. So then the function must be increasing. Well, everywhere it doesn't seem quite right, does it? Because it's got vertical asymptotes. Maybe I would say it's increasing on its whole domain. Cool. Everything feel pretty good? So in some sense, my goal today is do this same thing a few more times for the other 3 trig functions. So let's try to reason through what the graph of cotangent should look like, what the graph of secant should look like, and finally what the graph of cosecant should look like. And depending on timing, my discussion of cosecant might become abbreviated. So let's follow a really similar plan of attack for cotangent. So cotangent is cosine over sine. And let's start by seeing tangent had period pi, and cotangent is so similar to tangent. Maybe it has period pi? So take a moment and tell me, what is cotangent of x plus pi? What do you get when you start with cotangent x plus pi and simplify?
Just get cotangent in the end.
I bet you get cotangent in the end. So, people getting that to walk out? Anyone want me to actually fill in the details right now? Okay, seeing no heads nodding or hands going up. Cool. Yeah. Cotangent of x plus pi is the same as cotangent of x. So what's the period of cotangent? Pi. So if I can graph cotangent from 0 to pi, then I'll just repeat whatever it is that I see over the rest of the real line, and I'll have the graph of cotangent. And I'll follow the same plan now. It's made up of cosine and sine, so let's graph cosine and sine. And see what we see. So, maybe skipping to the conclusion. So cotangent is cosine over sine. So between 0 and pi over 2, is cotangent positive or negative? Positive. Between pi over 2 and pi? Negative. So that's something. I know that it's positive from 0 to pi over 2, negative from pi over 2 to pi. I mean, I guess it's interesting that that is so far the exact same as we saw for tangent, but I guess that makes sense if cotangent is the reciprocal of tangent. 1 over a positive number, still positive, 1 over a negative, still negative. Next up, let's identify the intercepts and vertical asymptotes. So cotangent, let's find its x-intercepts for us. So it's 0 whenever the numerator is 0. So it's 0 whenever cosine is 0. Between 0 and pi, when is cosine equal to 0? Pi over 2. This thing has vertical asymptote whenever you divide by 0. When is the denominator 0?
0 and pi.
0 and pi. So there's a vertical asymptote at x equal to 0, and a vertical asymptote at x equal to pi. And then we just have to like interpolate between. So I see this intercept at pi over 2, where it goes from positive to negative. So the slope's got to be negative-ish. And now I'll just try to achieve the correct vertical asymptotes. So it's positive over this whole stretch. So is cotangent going to go to plus infinity or minus infinity? Plus. So it's got to be positive. And down here it has to go down to negative infinity. So that now gives us the graph of cotangent from 0 to pi. Oops. And just like tangent, what could I do to now get the graph over the whole of the real line? Copy it, draw it again, and again. Yeah. Seem okay? So let's see. Let's try to lead off some things. Even or odd? Or not odd? Well, you could imagine fixing the origin, rotating around. You get the same graph back. The color coding screwed up, but the color coding was artificial. Increasing or decreasing? It's decreasing on its whole domain. And wherever it's defined, you see negative slope. Where are the x-intercepts?
Pi over 2 plus pi x.
There's an x-intercept of pi over 2 and then plus any multiple of pi. Where are the vertical asymptotes? At every multiple of pi, so pi k. And let's see, in order to do a quick sanity check, let's take a look at cotangent as compared to tangent. I'll try to keep the scale in the x direction consistent between the two. So just by looking at these two graphs, they look pretty similar, right? Maybe I'll even leave that blank. What could you do to go from, well, if I were to ask you, what transformation goes from this to that, what sequence of transformations would you want? Let's see, cotangent is like always decreasing while tangent is always increasing. Now, I don't know, like, they're definitely not just shifts of each other, but if you flip one over the x-axis, maybe you'll get something similar looking. What does flipping a graph over an x-axis do?
Change the sign of the y value.
Changes the sign of the y value. And in terms of the function, that multiplies the function by negative 1, I guess is what. So if you wanted to go from here to there, it looks like the first thing we might want to do is flip over x-axis. And when we do that, we see, well, I won't draw the whole thing. I'll draw maybe just this much of it. So there's a little bit of the graph of negative the cotangent of x. Does that line up exactly with the graph of tangent of x? What would you want to do to turn the pink graph into the black graph?
Horizontal shift.
Horizontal shift. By how much?
Half pi.
Half pi to the left or the right?
Doesn't matter.
Doesn't matter. So I guess let's just pick one. So apparently then, by looking at the graph, it looks like the tangent of x is the exact same as negative the cotangent of x, but then we need to shift by pi over 2. Let's do a quick check. So this is just to see if this is actually correct. Let's see if this agrees with the trig identities we got. So let's grab that old set of notes where we saw what happens when you add things like pi over 2. Oh yeah, that's right. This is the one set of notes that I didn't manage to keep. So if I, you're going to just tell me what to write. So what is tangent? What is cotangent of x plus pi over 2 the same as?
Negative tangent.
Negative tangent. Is that the same as what we wrote there, basically? So this bit of graphs, thinking about graphs, will cover us what we thought about just thinking about the geometry of these trig functions. And I guess most importantly, it agrees. So we can actually believe this result. People feel pretty good about this? Nice. Cool. So, what are the 6 trig functions that you write down when you're writing down trig functions? Sine, cosine, tangent, cotangent, secant, cosecant. So let's just keep on going down the list. I think we've got enough time to do secant in all the detail that I could possibly want. And then cosecant, maybe I will agree with you. So secant is exactly 1 over cosine. Cosine is 2 pi periodic, so secant will be 2 pi periodic. So let's try to graph secant from 0 to 2 pi by thinking about cosine. And we'll see what happens. So secant is 1 over cosine. So let's start with the graph of cosine. There's the graph of cosine from 0 to 2 pi. And secant is 1 over cosine. So let's try to start by figuring out where secant is positive. From 0 to pi over 2, is secant positive or negative? Positive, because cosine is positive. From pi over 2 to pi? Negative. From pi to 3 pi over 2? And 3 pi over 2 to 2 pi? Secant is 0 whenever the numerator is 0. When is the numerator of that fraction 0?
Pi over 2 and 3 pi over 2.
You answered the wrong question.
Wait.
It's no. The numerator is never
Oh.
positive. You answered the next question. So, what does that tell you? Does secant have any x-intercepts?
No.
No. Now say what you just said. The particle asymptote appears whenever the denominator is 0, whenever you divide by 0. When is cosine equal to 0?
Pi over 2 and 3 pi over 2.
Pi over 2, 3 pi over 2. And as one last thing to keep track of, let's encode that. Pi over 2. Yes. It's a good thing I didn't have it shifted then, because otherwise you would have seen that I drew a dot when I should have drawn a vertical line. So there are the vertical asymptotes. And one last thing, let's figure out where secant is plus or minus 1. Just so we have a few more points to draw. So let's go through it. If you wanted to solve this equation for x, what seems like a good first thing to do? Or alternately, if 1 over cosine is equal to 1, what can you tell me about cosine? Has to be 1, right? The only thing you can divide 1 by to get 1 is 1. Okay, good. But now check out the graph of cosine that's at the top of your page and just outside of view on the projector. When is cosine of x equal to 1 between 0 and 2 pi? Not at pi, right? It's minus 1 at pi. So that means it better be 1 at 0 and it better be 1 at 2 pi. But I mean, that answer of pi is an answer to something. When is secant equal to -1? At pi. And let's even just think about that value of 1. In absolute value, cosine is always less than or equal to 1. So 1 over cosine must then be big in absolute value bigger than 1. So secant is always bigger than 1 in absolute value. Secant will never be between these dots. Secant can't live there. So that means that from 1, it has to get bigger than 1, shoot off to infinity, come back in at -infinity, turn around here at pi comma -1, go back to -infinity. So there's the graph of secant between 0 and 2 pi. How can you now get the graph everywhere? Repeat. No, and I think I even did a decent job drawing all of those peaks and pits at the correct height. The same height. So there's the graph of secant. I don't know, let's read off some things from this. Where are the vertical asymptotes of secant? Let's start listing them. There's a vertical asymptote. What x value is that vertical asymptote?
Pi over 2.
Pi over 2. Where is that vertical asymptote?
3 pi.
3 pi over 2. Where's that vertical asymptote?
5 pi over 2.
Do you notice the pattern? Where are the vertical asymptotes? Pi over 2 plus a multiple of pi. So there's a vertical asymptote at x equal to pi over 2 plus any multiple of pi. Where are the x-intercepts? There aren't any, which we already saw. Like 1 over cosine is never equal to 0, and 1 is never equal to 0. Is this function even or odd? I hold an even. And let's see, as you start at 0 and go left or go right, do you get like the exact same image but flipped over the axis? So it's even. Which it better be, right? Because cosine was even. Everyone feel pretty good? So I guess I've even got time. I think I'll even finish early and have enough time to talk about cosecant. But I guess last time I also promised I would finish early, but then went right up to the end and celebrated because I let you guys at 30 seconds early. I don't think I'll go over. So secant is 1 over sine. So let's follow a very similar approach and see if we can't deduce what the graph of cosecant must be. So let's start with the graph of sine. So sine is, well, it's between sine and cosine. You know what those two graphs look like. Is sine the one that starts at 0, 0, or the one that starts at 0, 1? So sine starts here at 0. It has this max at pi over 2 comma 1. It's 0 again at pi, a min at 3 pi over 2 comma minus 1, and then back up to 2 pi comma 0. And cosecant is 1 over secant. Let's start by figuring out where it's positive or negative. Positive or negative? Positive. still positive. Negative and still negative. Cosecant is 0 when that numerator is 0. So when is cosecant 0?
Never.
Never? No x-intercepts. Cosecant is 1 over sine of x. It's going to have a Vaughn asymptote whenever you divide by 0. But when are you going to divide by 0 if x is between 0 and 2 pi?
Pi, 2 pi.
Pi and 2 pi, and where else? One other place.
0.
At 0. Because, well, I guess I didn't say it aloud, but by between, on this page, I mean the closed interval, so I include 0. So, there's a vertical asymptote at 0, a vertical asymptote at pi, a vertical asymptote at 2 pi. And just like last time, somehow 1 is a special value because 1 is like the biggest that sine can be. So it's like the smallest that cosecant can be, in absolute value at least. When is cosecant equal to 1?
Pi over 2.
At x equal to pi over 2? Right, because how do you see that? Well, that should be, well, when is sine of x equal to 1? By, I guess, taking the reciprocal of both sides. And when is sine of x equal to 1? Well, you look at the graph at pi over 2. So you see that point at pi over 2 comma 1. When is cosecant equal to negative 1?
3 pi over 2.
3 pi over 2? Because of that point. And those plus or minus 1s are like extreme values. So sine should always be bigger than 1 or less than negative 1. No, cosecant should be always bigger than 1 or less than negative 1. So you should see a valley there and then shoot off to plus or minus infinity. Should see a peak there and shoot off to minus infinity. People feel pretty good? And now you probably have a pretty good idea what I'm going to do next. How can you get the graph of the whole function? Again. And let's close by just reading off some facts. Even or odd. I hear an odd, but it sounded like it had a question mark at the end of it. So
I
that's
am putting an exclamation point now.
okay. Well, it's too late. I'm still going to do the rotation. All right. So if you want to visually check if a thing is odd, pin down the origin, flip it 180 degrees. Does that give you the same graph back?
Yeah.
So it's odd. Since it's odd, it can't be even because there is only one function that is both odd and even. And maybe I'll continue to just let you meditate on what that one function is. Or maybe you'll just tell me that it's 0. Where are the x-intercepts? There are none. Where are the vertical asymptotes? Where you multiple of pi, everything is pi k. And I guess another thing you can see is if you, I don't think I will do this, I think I will actually do it 2 minutes later. You could sketch the graph of cosecant on top of this, and you would see that cosecant and secant are just like shifts of each other. Which they better be, because sine and cosine are just shit systems. So you can see all of these algebraic facts now from the graph. And I guess maybe I'll give you this payoff. What we'll do in the not too distant future is we'll start solving trigonometric equations. And one thing that we'll do to see what the solution should be is we'll draw a graph and visually see where these things cross horizontal lines. Cool. So let's see. At this point, everyone has a review for that talk. I'd consider looking at it. That seems like a good thing to do over the weekend. And I think a few people had intended to turn things in on Thursday, but then didn't come to class on Thursday. So you should turn things in now if you're one of those people. I don't remember who, but I remember there being people.
Do you want us to sit down to review over the weekend, and then Monday we'll go over?
That seems like a good thing to do. Yeah, because I think the exam itself is on Wednesday. And on Monday, that's a day for review. That seems like a good way to do a review day. If you already know all the answers, except for the ones you don't, you know the rest.
Okay, thank you.
Oh.
I had emailed you about my dog and then the road yesterday. I live half hour away. So.
Yeah, I got you.
Thank you.
Yeah, I'm sorry to hear about your dog.
Thank you.
You office hours at 2 today, right?
Yes.
Okay.
You're going to send me an email last night about your grades?
No.
Oh, okay.
I wanted to look over the review guide, so I did it all last night, and I was hoping that we could look through it and like see if I have the correct answers and work through any like problems that I had trouble with.
Perfect. Another thing you could do in advance is a lot of the questions. Now you're not allowed to calculate on like the actual exam.
Right.
I can't stop you from using a calculator. You should use one in the meantime. So for a lot of these, like if you want to compute the domain, have a computer graphics.
Okay.
Right. All of the x values you see will be the things in the domain.
Okay.
Oh no, this is like solving.
Right. That's
So
what I did.
take the equations you get, take the solutions you get, plug them in.
Right.
So check everything you can using machine faults.
Yeah, I did. I just wanted to like check in with you that like I did it right and that I had the correct answers. And then anything that I didn't, I thought we would like go over it maybe. So.
Yeah, great.
Okay. Thank you.
Perfect. Thank you.
That's good.
From inside of this building, high up in my office, though, there was an excellent view of the thunder snow. I'd never actually seen lightning in a snowstorm before this. It was a fun view.
Yeah. Oh, that's sad.
I should stop the recording.